Okay, my friends, so I've brought our little linear model from the whiteboard into Excel. You don't have to do this. If you're following along in Excel, you don't need to do this if you don't want to. I just wanted to show you the deltas, like we looked at outside, in formula form. I wanted to show you how you can actually code that formula that I did out on the board in Excel. So what I'm going to do is I'm going to click right here, and I'm going to go equals, and I'm going to click that 5 minus that 3. So what I'm doing is actually subtracting the 5 minus this 3 and pressing enter, and then I'm going to drag that down. And those are those 2's that we saw on the board outside. I'll make them red because I think I made those red outside as well. Now you might notice they're not quite as pretty as the ones we did outside because I was able to draw diagonals and Excel is limited. I couldn't do the diagonal, but that's okay. We can live with this, I think. Here, we can also do the deltas on the independent variable by subtracting the same way. Okay, dragging that down, and if we want to feel saucy, we can color it blue. Make it match. Okay, so you see the constant change of the dependent variable with the constant change of the independent variable. And as is no surprise to anyone, I don't think, if you were to graph these using our scatter plots, that is going to be a perfectly straight line. That's the whole point, is that it is, oops, let me see if I can delete that. And if you wanted to fit a trend line to it, no surprise, it's a perfectly straight line. Okay, so now what I'd like to do is focus on, I'm going to delete all this, and focus on instead our savings account over here. Now you might notice, matter of fact, I'm going to undo this and I'm going to bring the delta characters over just because they were fancy. And then I'm going to delete all this. Okay, we can look at the deltas the same way for the independent variable, which in this case is years. So we can do equals 1 minus 0. And this is going to be very boring to you because it's going to be 1 all the way down because I increased them by 1. But now let's look at the deltas in the amounts in the accounts. So what I'm going to do is I'm going to go equals that guy minus that guy. So that's my extra dollar. And I'm going to fill this down and color it red. Now what do you notice? What do you notice that's different here than in the linear model? Hopefully what you're noticing is these aren't all the same. And as a matter of fact, they're increasing as we go down. While these are staying constant, these are increasing as they go down. So that's the first hint that we know these aren't linear. If these were linear amounts, then these would be the same year to year. Here, I'm gonna make this be a linear amount and then undo what I just did. Instead of having it be what it is, I'm going to take the previous amount and add $1 to it. And then I'm going to drag that down. There, now it's linear because that's adding $1 per year to the bank account. But that's not how bank accounts work. Bank accounts don't accrue money by adding fixed amounts of money per year. They increase by adding percentages of money per year. So let's get rid of that, put our old formula back in. What I'd like to do real quick before I go any further is I want to graph our data and see if we see anything. Might be a little bit hard to see. Might be a little bit hard to see. So what I'm going to do is I'm going to change the scale a little bit to make it easier to see. I'm going to start the minimum at $100, which is where it begins. And I'm going to have the maximum go up to 135. And then we're going to take a look at that. All right, still kind of hard to see. I'm not going to lie, it's still kind of hard to see. But if I go and I go to a trend line, if I go to more options, there's the linear one. Now, if you take a look at that linear trend line right there, you might notice something. The points start above the line, then drop below them, and then go back up again. That means this data's not linear. Even without the trend line, they sure look linear, don't they? I mean, if you looked at that quickly, you would say, oh, I mean, that looks extraordinarily straight. But let's do something. Let's do something. Let's continue this out for maybe a couple hundred years. You can really see it now. Now you can really see it. It's definitely not a line. It's definitely curving. And if you take a look at the trend lines, go to more options, that line obviously doesn't fit it at all. And you click on exponential, it's maybe kind of hard to tell, but that exponential curve is laying right on top of our data. And that's because this data, the data of financial math, is exponential. What I'd love to do right now is wander back out to the board and show you why these amounts are increasing exponentially. Because when we say things are increasing exponentially, I think a lot of people use that as a synonym for the word fast. And that's maybe possibly partially true. But there's a mathematical thing that is happening from year 0 to year 1 to year 2 to year 3 to year 4 that actually involves an exponent. That's why it's called exponential. So let's go back out to the board and then figure out where the exponential behavior is happening. Meet me outside.